Welcome to another mathematics video tutorial brought to you by Ronique Bernard, another CDP Maths Lab Teaching and Learning Center production. Our topic for today is sets. Instructions. Read the following instructions. This lesson was not designed for entertainment. It was designed to be interactive. So therefore, we are asking you to follow each instruction given to you by the tutor. If not, this video will be very useless to you and boring. So please follow each instruction. Remember to do all the try this questions before starting your worksheet. Content of lesson. Number 1. Defining terms and symbols used in the set language. And number 2. Relationships between sets. Terms and symbols. A set is a collection of things which shares something in common. The symbol used to represent the phrase "the set of" is braces. So this symbol here means what? The set of, which are braces. For example, the set of vowels. So this phrase can be rewritten as, we're talking about the set of vowels. It can be rewritten as what now? So we'll place the word vowels in between the what? Braces, which means what? The set of. So when you see the braces here, we are speaking of the set of vowels. Okay. Pause your video and try this one. The set of even numbers less than 20. Your answer is even numbers less than 20. If you got this correct, give yourself a clap. So therefore means you should put the braces right here, and then you write the phrase even numbers less than 20. That should be your answer. So you give yourselves a clap. Defining a set. A set can be defined by describing its sets. For example, V is equal to the set of vowels, which reads as V is the set of vowels. Okay, so notice now where we put the word. So when we're describing a set, we just use what? Words to describe the set. So the word vowels here is describing the set of vowels. So that's how we define a set, by describing. Try this one. Describe the following set. N is equal to John, Mary, and Pam. The answer is N is equal to what? Names. Because guess what? John, Mary, and Pam are a set of names. So this is saying the set of names. Terms and symbols again. An element or member of a set is any object, thing, place, or animal that belongs to the set. For example, the letter I is a vowel. So therefore, saying the letter I, this symbol means what? Element or member of. So this symbol means the element or member of. This reads that I is a member of the set of vowels. So I is a member of the set of what? Vowels. Very good. Defining a set. A set can also be defined by listing all the elements in the set. Okay. For example, V is equal to what? Set of vowels once again. But this time we are going to do what? List all the elements in the set. So, would be what? Set V is equal to A, E, I, O, U. So note now, we describe the set using a word here, and we can also define the set using listing all the elements of the what? Set. So A, E, I, O, U are elements of the set of vowels. So this is another way of defining a set by listing all the elements of the set. Very good. So try this one. List the elements of each set that is described here, even numbers less than 20. So pause your video now and try this one. The answer is 2, 4, 6, 8, 10, 12, 14, 16, and 18. So all these numbers are what? Even numbers less than 20. So in this case now we have list the elements of the set of even numbers less than 20. And here again we are defining a set. Order of a set. The order of a set is the elements contained in the set, or rather, the order of a set are the elements contained in the set. N, where you see these two brackets now, note, normally we have a capital letter between these two brackets, but this symbol means, where you see common N and open and close bracket, means the number of elements in the set. So this symbol here means the number of elements in the set. For example, if set V is equal to A, E, I, O, U, then the number of elements in what? Set V. So notice now, capital V here. So we are saying, so the name of the set is placed between the two what? Brackets. So the number of elements in set V is equal to 5. So note now, if we count A, so it is 1, 2, 3, 4, 5. So 5 elements are in set V. Try this one. If C is equal to 2, 3, 4, 5, 6, and 7, what is the number of elements, or what are the number of elements in set C? Your answer is number of elements in C is equal to 6. Subsets. A subset is a set which consists of some or all of the elements of another set. This symbol here means is a subset of. So we're saying that this symbol here, look at it, look where the pointer is, means is a subset of. So that's the symbol used to represent is a subset of. For example, A is equal to what? Factors of 10, and B is equal to what? Even numbers less than 20. You may pause your video and write this information down. Now note, this line that cuts across the symbol means what? Not a subset of. Step 1. So the first thing you're going to do is what? List the elements in both sets. So therefore, the factors of 10 are what? 1, 2, 5, and 10. And the even numbers less than 20 are 2, 4, 6, 8, 10, 12, 14, 16, and 18. Step 2. So the second thing you're going to do, look to see if all the members in set A is in set B, or look to see if all the members in set B is in set A. So note, so A is equal to what? 1, 2, 5, and 10. Now notice now, we find a 2 in set A, and what? We find a 2 also in what? Set B. So far we have 2 in set A and 2 in set B. We find a 10 in set A, and we also find a 10 in set B. So we have 2 members that we found both in set A and set B. But note, there's one is not in set B but in set A. 5 is not in set B but is in set A. So all the members of set A are not a part of set B. So therefore set A is not a subset of set B. And why? Because all the members of set A must be in set B for it to be a subset of set B. Note. So note now that set A is not a subset of B, nor B a subset of A. Subset. A real example of a subset. Now C is equal to what? Factors of 2, and D is equal to factors of 10. So set C here, we have listed them. 1 and 2 are factors of what? 2, and D are factors of 10. So 1, 2, 5, and 10. Now if you notice now, look into set C, what do you see? 1 and 2. Look into set D, do you see 1 and 2 as well? Yes. So all the elements in set C are in set D. So there it is. So therefore set C is a subset of set D. So we write C is a subset of D. Good. So here it is again. So 1 and 2 are in this circle here, and 1 and 2 here. So as you look again at all the elements in C are in D. So therefore C is a subset of D. Try this question. Question number 1. State whether the relationship between the two sets is a subset or not a subset. Here it is. A is equal to 2, 3, 5, 7, 11, and 13. And set C is equal to 1, 7, and 13. Now question number 2. State whether the relationship between the two sets is a subset or not a subset. And here it is. A is equal to 2, 3, 5, 7, 11, 13, and set D is equal to 3, 5, and 7. So pause your video now and try these questions. Answers. Answer for number 1 is C is not a subset of A, and B, D is a subset of A. These two should be your answers. If you got them wrong, play over the video again up until the point before you get to these answers. Using diagrams to illustrate subset. Now take a good look at what is happening here and listen to the video clip.
Set D is in set A. I repeat, set D is in set A.
Okay, so he was saying that set D is in set A. Now note, the elements in set A are what? 2, 11, 13, 3, 5 and what? 7. So note again, the elements in set D now are 3, 5 and 7. So all elements in set D are in set A. Now listen to the clipping again.
If you take a good look at the second diagram, you see that the numbers 2, 11, 13, 3, 5 and 7 are all a part of set A. If you look at 3, 5 and 7, which is in set D, all the members in set D is a part of set A. So all the members of set D is a part of set A.
Good. So all the members of set what? D are part of set A. So this is a diagram that you'd use to illustrate a subset. So when you see a circle in a circle, it means one set is a subset of the other set. So D is a subset of A.
Try this question. Okay, draw a diagram to illustrate the following information. Set A is equal to multiples of 2 less than 6, and set B is equal to multiples of 4. You must be wondering, what are multiples of 2 and factors of 4? Follow me before you pause your video. To get multiples of 2, this is what we do. Now 2 must be multiplied by any number. So 2 times 1 is 2. So this 2 now is a multiple of the 2 here. To find another multiple, we multiply the 2 again by another number. Let's use 2. So 2 times 2 is equal to 4. So 4 is also a multiple of what? 2. We multiply 2 by another number, which is what? 2 3s 6. So 6 is also a multiple of what? 2. You can say 2 times what? 4 is equal to 8. So what we're saying is that any number multiplied by 2 will give you what? Multiples of 2. So multiples of 2 what we have so far are 2, 4, 6 and 8. Now to find factors of 4. Now to find factors of 4, we are seeing that any number when multiplied, any two numbers when multiplied that will give us 4 are both factors of what? 4. So 1 and 4 are factors of 4. Now 2 times 2 is also what? 4. So therefore 2 is also a factor of 4. So all the factors of 4 are 1, 2, and 4. These are the factors of 4, and these are multiples of 2. Pause your video and try this question.
The answer is 2 and 4 in set A are a subset is a subset of what? Set B. So your diagram should look like this. If your answer is wrong, go back to the example and see where you went wrong. Disjoint sets. Disjoint sets are where two sets have nothing in common. For example, A is equal to multiples of 4 less than 10 and B is equal to factors of 5. So we're saying multiples of 4 less than 10 and B equal to factors of 5. So we have listed them. So the elements of A are 4 and 8 and the elements of B are 1 and 5. So 4 and 8 are multiples of 4 less than 10 and 1 and 5 are factors of 5. Now if you notice now, A and B have nothing in what? Common. So therefore they are disjoint. So we have a circle with 4 and 8 in set A, and we have a circle set B with 1 and 5. So notice now there's no relationship between set A and set B. Why? Because they don't have nothing in common. They don't share any elements at all. So therefore they are disjoint. Intersection of sets. When two sets intersect, they have common what? Elements. For example, A is equal to factors of what? 10, while B is equal to even numbers less than 20. Now, intersection of sets. So we're going to list the elements of A first. So we have 1, 2, 5, and 10, and then list the elements of B, 2, 4, 6, 8, 10, 12, 14, 16, and what? 18. Let's draw our diagram. So we have A here having 1, 2, 5, and 10. And set B has 2, 4, 6, 8, 10, 12, 14, 16, and 18. So let's look into both sets now and see what is common. So 2 here and 2 there. So we have 2 in set A, 2 in set B. So we realize that A and B intersect because they share both what? 2. So 2 is in both sets. What else do they share? Let's look again. We find a 10 in set A. You saw it? Good. And find another 10 in set B. So therefore, set A and B share 2 elements, 2 and 10. Very good. So this symbol here means intersect. So we say A intersect B is equal to what? 2 and 10. So these two numbers here are the elements in both set A and set B. And what's next? The number of elements in A intersect B is equal to what? 2. So if you count these two numbers, it's equal to what? 2. So we are saying the number of